So we've got two spinners. One has the numbers 2, 3, 4, 5, 6, and 7. And the second one, spinner B, has the numbers 2, 3, 4, 5. They're equally likely to stop on any of the numbers. And the two spinners are each spun once. And the number is, or the numbers on the spinners are recorded. So find the probability that spinner A stops on a number less than 4. Well, there are only two numbers less than 4. So 2 and 3 out of a total of 6 numbers. So that would be 2 over 6, which would be fine to write your answers out. You don't have to simplify, it doesn't tell you to. But you could simplify that to 1/3. So easiest to write this as a fraction. Spinner B stops on 6. So what's the probability spinner B stops on 6? Well, it can't. There is no number 6 on the spinner B. So the probability of that then is going to be 0. Okay, then part C, spinner A and spinner B both stop on the same number. But there's quite a few probabilities here then. So either it's going to stop on a half and a half. Sorry, half and a half. It's going to stop on 2 and 2. So they both stop on 2. The probability spinner A stops on 2 is 1 over 6. And the probability that B stops on 2 is 1 over 4. So the probability of both of those things happening, A and B, remember and is multiply, is a 6 times a quarter. But then there are more possibilities. So there are more probabilities. You've got 3. So the probability they stop on 3 is also a 6 times a quarter. And they might also stop on 4 and also on 5. So this could happen 4 times. So obviously the quickest way to do this, quickest way to work this out, is instead of doing a 6 times a quarter plus a 6 times a quarter, yada yada, is just do a 6 times a quarter times by 4. Because this is going to happen 4 times. So if you do that, pop it in your calculator, you should get a 1/6. Which is your final answer. Then next one. So now we're looking at one number being prime and the other one not being prime. So the prime numbers then are going to be 2, 3, 5 and 7. One's listed. I'm probably going to copy the stuff across from before onto this page, which is what I've done there. So we have to figure out then from spinner A then, which numbers are the probability, just from spinner A, probability of getting a prime number is, well, you got, that's prime, 1, 2, 3, 4. So it's 4 over 6. And then for probability of it not being prime is going to be 2 over 6. Now for the other one, for B, so that was A, and B, probability it's prime is going to be, we've got 2, 3 or 5, so it's actually more likely. So you got 3 out of 4. And then probability it's not prime is 1 over 4 then. So if it's prime, the number is prime on spinner A, so the probability is 4 over 6. And then it has to be not prime on the other one. The probability it's not prime on B has got to be 1 over 4, because it's 3 over 4 for the probability to be prime. And then the other way around, the other way it could happen is probability, the number the number on A is not prime. So what's the probability of that? That's 2 over 6, because the probability is prime is 4 over 6. And that means if that's not prime, it's the other number on spinner B has to be prime. What's the probability of that? That's 3/4. So those are the only two ways it can happen. Either the first instance here, where spinner A is prime, and then you times by the multiply by the probability of the number on spinner B being not prime, or the number on A is not prime, and then the number on spinner B is prime. That's the only two ways it can happen. The only two ways it can happen. So you're going to have to work out those probabilities and then add them together, which should be 5. You put it in your calculator. 5 over 12. Now, the last one's really easy to get wrong, just to make a careless mistake. So you've got to work out the probability that the sum of the numbers is a multiple of 3. So here I was just really quite systematic. So I started with A, and then looked at the combination of those numbers it would make with B. So I started with 2, and then looked at all the combinations it made with B. So it'd be 2 and 2. Is that a multiple of 3? No, because the sum is 4. 2 plus 2 is 4. 2 and 3 adds to 5, so that's not. 2 and 4 is. So I'm going to write it down. So you get 2 and 4, and then 2 and 5 is the last one, so no. So that's 2 done. But, you know, there's a lot of these. So then 3 and 2, no, that sums to 5. Then just going through the list, 3 and 3, that is, so I'll write it down. 3 and 4, no. 3 and 5, no. Then go on to 4. So 4 and 2 is, that's 6. 4 and 3, 4 and 4, 4 and 5. 4 and 5 is, I've got to write it down. So I've got 4 already. Now I'm moving on to 5 then on A. So I've got 5 and 2, no. 5 and 3, no. 5 and 4, yes. 5 and 5, no. That adds up to 10. Only two more to go now. So 6 and 2, no, that's 8. 6 and 3, yes. 6 and 4, no. 6 and 5, no. Nearly there. And moving on to 7 then. 7 and 2 is yes, that's 9. 7 and 3 is 10, no. 7 and 4, no. 7 and 5, yes. So very systematically going through the list, I've identified there 8 different combinations. So yes, that you'd get a multiple of 3. Right, that is 8 out of what though? So you've got to work out then how many outcomes there are in total. It's not too difficult. You know, if we recall maybe looking back at when you're rolling 2 dice, you've got 6 faces on one die, 6 faces on the other. Total outcomes, you've got 36, 6 times 36. So here we've got 6 numbers on one, 4 numbers on the other. So the total amount of outcomes you can get, if you drew, you know, a sample space diagram, for instance, if you wanted to, you'd have 24 possibilities, 24 outcomes in total. So it's out of 24. So 8 out of 24, which you, if you wish, you can simplify to 1 over 3.